So, this topic is something that maybe you've seen before, but there's a good chance that you haven't seen it before. So, you can tell me now if this looks familiar to you. Matrix.
What? It's a movie?
Yep, sure is. Keanu Reeves. I can't tell you what the Matrix is. You need to see it for yourself. Yes? Yep. So, apart from the movie, in maths class, do you know what it is?
Yeah.
Yeah, what is it?
Math.
Yes, numbers related for sure, yeah. Matrix will be related to what you've been doing in the first few lessons with the line and intersection and all this. For the moment it might not seem to have any relationship to it, but what exactly is a matrix? All it really is just a block, a grid, an array of numbers, a collection of numbers. Like for example, I can call this a matrix. I can call this a matrix. And for example, I can call this, I can call this a matrix. Okay, these are all examples of matrices, blocks of numbers. Okay, so this is like a new thing in maths. These are three different examples of matrices. This one, unsurprisingly perhaps, is called a square matrix because it looks like a square. It has 2 by 2. Yes? Now, what name might you give to these ones? Yep, that's right, but there's another word for it too. No, like a single word to describe the shape. Do you know? Not quite this, no.
Line? Line?
You're getting closer.
Line.
What would I call these? I'm not being clear actually. These are called rows. And then these would be called columns. Very good. So what would you call this matrix, do you think? You would call it a row matrix. And this one here? A column matrix. And then this one here is a square matrix. So this is a row matrix, a column matrix, and a square matrix. They're the three types of matrices you will have to concern yourself with for this semester. Those three.
Can you write the full word, please?
I could. Yeah.
Do we get questions like, what type of matrix is this?
You could get that, although that has never happened before, but you could get it. Yeah. Oh yeah, let me tell you something here. Right, pause that. With the three matrices here, they have new algebra rules. Okay, so we'll look at the new rules that we have for these. The first rule is how to add a matrix with a matrix. So for example, how might you add these together? Well, you could almost guess what the answer should be. What do you think? Yeah, 1 plus 2, which is 3, and 2 plus 3 is 5. That's what am I? Sorry, 5. Yeah. No, I realised I said 5, and then like, no, that's wrong because I heard you say the other number. And then like, well, no, wait a second, I was right the first time. Okay, so that's fine, but notice that it actually doesn't work if it's like this. Okay. You're not allowed to add these together. Why not, do you think?
Because this is a row.
Yeah, they're different type. You see, if you look here, I suppose you could add this number with this number, I suppose, but there is no neighbour to that number. You see, the 2 has nothing to match it with.
But you could multiply.
Yeah, but we're allowed to multiply them, which is the next rule that we'll do that now as rule number 3. But for the first rule, adding and of course subtracting, which is the same thing really, it's just what you might expect. You know, 1 plus 2 is 3 and 2 plus 3 is 5. That's okay, yeah. Now let's look at the next rule, which is a matrix multiplied by what's called a scalar. And look, you might not know this word, but all scalar means is a single number, like x, for example, okay? And again, this is a rule that you could almost guess. For example, 4 multiplied by 1, 2, 3, 4. Anybody want to have a guess at what they think the answer would be? 4, yeah, 8, 12, and 16. So adding is easy. Scalar multiplication is easy. The difficult rule is matrix and matrix multiplication. So I'll just give you a minute to make sure you have these two rules down, and then we'll do the rule number 3. So please tell me who has seen these before. Yeah, okay, all right, and then the others haven't. Some high schools do them, some high schools don't. For example, in Ireland, when I was in high school, we did them, but now they're no longer done. So it's country by country. It's not a universal topic.
No, but
why are they not longer done and they still grade them in the exams?
I mean for like the Leaving Cert, which is like for Irish students. Okay, this program is it's more like international, you know. Whereas the Irish specific one, they don't do matrices anymore.
Like the exam, like this topic is pretty long, okay? For what I think, like we studied a lot for it.
No, don't worry. We will just do.
I'll tell you why.
Yes.
And then in the exam, it's only one question that shows up.
It would usually be one short question and half a long question in the exam, but we won't spend too much time on it. We will just stick to these small matrices. Of course, they can get bigger and much more difficult, but we will stick to 2 by 2 maximum for semester 1. Okay. Now the last rule, I should go to a new page actually, is a matrix multiply matrix. So let me give you a small one to begin with. So this is matrix multiply a matrix. Okay, so for example, 2, 3 times 4, 1. Now, what do we think the rule is here? Well, what you might guess is it's 2 multiply 4 and 3 multiply 1.
No.
And it's not quite
2,
that.
4,
Yeah.
2, 1. And then 3, 4, and 3, 1.
Oh, you think so too?
Yeah.
Oh no, sorry, afraid not. You're thinking of the next one I might be doing. So this one here is smaller. Here and these get multiplied, but the way you multiply them as follows. You do 2 multiply 4, which is 8, and then you do 3 multiply 1, which is 3, and you add, always add the result. And that's it, okay? This is what you might call row-column multiplication. One row multiplies one column, like this. So please write this example down. And you can put in some arrows or something to help you. So it was this one multiplying this one, and then it was this one multiplying this one.
So it confuses me. Which one is the row? Is it?
This is the row,
Yeah.
and this is the column. So row, column. Okay, is that okay? That's not too bad, but now the difficult one. If you have, let's say, a square matrix and a square matrix. Okay, this is the trickier one. First thing you should know is that a square matrix multiplying a square matrix makes a square matrix. Okay, so you know that the answer should be a square and how many numbers? 4 numbers. Okay, and the procedure is you start off with the row here and you multiply it by this column here. So 1 times 2, 2,
2 times
and 2 times 0, 0. Add the answers together. So 2 plus 0, isn't that what we said? Goes there. Okay. Next one here. This row again, multiply this column. 1 times 1, 1 times 1, 1. 2 times 4, 8. So here goes 1 plus 8. Now we go to the next row here. This one with this one. 3 times 2, 6. And then 2 times 0, 0. And then finally this row with this row. 3 times 1, 3. And then 2 times 4, 8. So you get as your answer 2, 9, 6, 11. And that's the answer then. Okay. Bit tricky, but the good thing about this topic is it's very automatic, very mechanical. You know, do this, do this, do this, do this. So students usually like this in the exam because it's a way to get full marks in a question. Okay. Yes, Hassan.
3 multiply 4 in the end, yeah. 3 multiply 1.
The last one was 3 multiply 1 and 2 multiply 4. Yeah? It was, let me highlight it here. This one multiplying this one. So first was 3 multiply 1 and then secondly was 2 multiply 4. So 3 times 1 is 3, 2 times 4 is 8.
You know what's an easier way? Like every time I see a matrix like this, I just draw a line up and then a line down.
Yeah, I wanted to do that, but I felt it might look a bit messy if I draw lines in.
On the top and on the side, not on the matrix.
Oh yeah, to help you remember. So it's this way for this one.
Like this and then...
This one here. Yes. That is important. Don't mix this around, okay? It doesn't work if you do column and row. It has to be row and then column. Has to be. Okay? Row and column. Now, just to make sure you're happy with this, I'll give you one to try and then I'll do the answer with you, okay? So I want you to try this for me. 2104 multiply 1232. Oh yeah, we'll look at it together now, yeah. So if you haven't finished, you can double check your calculations, make sure they're all right. Okay. Some people have it finished now, a few people do, yeah? Okay. So the first one is 2 plus 3. So should be 5. Yes. The next one is 4 plus 2. 6. Then the next one is 0 plus 12. Because, yeah, it'll be this one and this one. So it'll be 0 and 12, which is 12. And then the last one would be 0 and 8. So 8. Now, can somebody tell me something interesting about that example I just gave you? Yes.
If you switch
Yes,
it,
that's the one. So the example I gave you is the same as the example I did, except I just swapped the two matrices around. See? I put this one now in the front. It's a bit surprising that the answer is different, but for matrices the answer is different because the order is important. Example in regular maths. 3 times 2.
What's 12?
One sec. 3 times 2? 2 times 3? 6. The same way. But for matrices it's not. Yeah, what's your question?
12.
Sorry, that's a 12 there, yeah. Because it was 0 times 1, which is 0, and then 4 times 3, which is 12.
Oh, yeah.
Okay, so the order is very important. So this is a very important rule, or rule to write down, I suppose. Generally speaking, A times B in matrices does not equal B times A. Okay, so please be careful. Make sure you keep them the right order. Now, of course, they will be equal in some special cases, but generally speaking, A times B will not equal B times A. We'll look at some special cases later next week, I think. Yeah. Right. One more here to do as an example. Who thinks they can tell me how I might do this one?
You do it the same way. You
How?
multiply by itself.
Very good. Multiplied by itself. Okay. Question, Ahmed? Yeah.
Just which player? Okay, that's
Which first?
Okay, well, we'll do another example now so you can watch. Yep.
Sorry, is that the power 2?
Yes, power 2. Os 2. Yep. That's right. Is right, yeah? Yes, okay, good, yes. So this one as an example. I'm surprised nobody else noticed that I just used Arabic there for power.
Yes, and
Yeah, you
Yeah,
just asked
yeah.
you is English word.
Yeah, you all seemed like this was perfectly normal, you know. No, it's not the English word, it's power. Okay, so you multiply it by itself. So we'll go through the process again, okay? So firstly, it's this row with this column. So that would be 2 times 2, and, 4, and 3 times 1, which is 3. So we get 7 there. Next is this row with this column. So 2 times 1, which is 2. 1 times 1, which is 1. 2 and 1, 3. Next is this row with this column. 3 times 2 is 6. 1 times 3 is 3. 6 and 3, 9. Finally, this one with this one. 3 times 1 is 3. 1 times 1 is 1. 3 and 1, 4. And notice it is not 4, 1, 9, 1. You know, the square doesn't just go on each of them. That you have to do it this way to get the right answer. Okay. I should also say, maybe as another example, do you need me to leave this here or I go down a bit? Just as another example, which is more difficult than row and column, but easier than square and square, which would be like this, for example. Square and column. Okay, that one's not as difficult, but just to do it so you can see it, this row and this column, like normal. So 1 times 1, 1, 2 times 2, 2 times 2,
4.
4, add together you get 5. And then this row again with this column, 3 times 1 is 3, 1 times 2 is 2, 3 and 2, 5. So you see it's not quite as long and as difficult as square by square. But
When multiplication and you don't do it neatly, it's just, you're just gone.
yes, take care of writing it down.
Yeah.
Okay, so,
We don't understand.
but this is easier than the square by square. So what part is confusing you?
I don't know.
You want to see another one?
Yeah.
Okay, I'll do another one here. So, as another example, let's say 1, 2, let's put a minus in it. -1, -1, multiply 3, 4. Okay? What do I use first here, the row or the column? Row or column? Row. And then here, column. 1 times 3, 2 times 4, try again? 8, yeah. And 3 plus 8, 11. Okay? Row, column. -1 times 3, -3, -1 times 4, -4, -3 and -4, -7.
Can we swap them?
Can these be swapped? No. Don't ever swap
Keep
your
it normal.
matrices.
Keep them.
Just keep it as it is. Yeah. In fact, you can't actually do it if it's swapped, because if it's swapped, look what happens. What do I do here, row or column?
You just do row.
I can't, yeah, but I need row here. How many numbers in this row?
1.
1. And then column here. How many numbers in this column? 2. So there's no, you can't pair them up. So you can't actually do this. So interesting. This is possible, but in this example, this one is impossible. So my point again is you really need to be careful with the order here.
I have a question.
Yes.
Sometimes they put questions out that you can't solve them.
No, that won't happen. Don't worry, don't worry.
I got that in my IG exam, and they were just
They give you a multiplication that you can't actually do.
yeah. And
Yes.
then I found out that I could just write impossible and possible.
That is what we call a troll question. And that won't happen in the exam. It shouldn't. It's not a fair question, because the purpose is to see if you know how to do it. And you can't do it if it's
And it had 2
impossible.
marks.
And what's that?
It had 2 marks on it
Just 2 marks out of 100 for the exam?
for the exam. Yeah.
So you lost 2% by trying to do it. Yes. Don't worry, this shouldn't happen for you. Okay, are you happy with this now? Yes? Okay, now, for questions to try now,